Hi students, welcome to my channel Chemistry Demystified. So nowadays I am covering all the book back exercise from the chapter Thermodynamics from class 11 Chemistry. So today I am going to solve the book back exercise question number 6.3, 6.5, 6.11, 12 and 14. So all these questions are based on the concept of standard enthalpy of formation and combustion and some mixed data. So I am going to tell you the basic concepts behind these questions and I am going to solve it. Okay, so please watch it carefully. So what is standard enthalpy of formation and standard enthalpy of combustion? See, this is the most important part of the thermodynamics, students. So most of the questions will be asked in this session only. So there will be a reaction. So you know that for each and every reaction there will be some enthalpy change, isn't it? So you have to calculate the enthalpy change of a particular reaction. So what they will do is sometimes they will give the data of formation data. Some enthalpy of formation data would be given, standard enthalpy of formation data would be given, or enthalpy of combustion data would be given, or sometimes the mixed data will be given. So if you know this trick and the formula, this is very easy and you can gain more marks from thermodynamics because most of the questions will be taken from this segment only. Okay, so before that I will brief the concept. See, standard enthalpy of formation. Okay, so it is represented as like this. So F stands for formation and this symbol stands for standard. Okay, this is enthalpy change. Then what is that? The change in enthalpy when 1 mole of a substance in the standard state, okay, is formed from its pure elements under the same condition. So what is standard state, students? So when the pressure is equal to 1 atmosphere and the temperature is equal to 298 Kelvin, okay, from the pure elements under the same condition. So what does it mean? Suppose if you have to prepare water, okay, so you can prepare only 1 mole of water. Okay, so the formation of, see the enthalpy change, the change in enthalpy when 1 mole of a substance. See, so I am going to prepare water, so and that should be in 1 mole. See, I am going to prepare this, so I am writing in the product side. Okay, students. So what are the ingredients here? See, hydrogen and oxygen. So what I have to choose, the reactants, what I can choose is only the elements in its pure form. So how did I know this? See, there are some pure elements. Okay, so we have arbitrarily assumed them as 0. Why we have arbitrarily assumed them as 0? Because these elements occurs in nature. We did not supply any energy to prepare them, isn't it? So they are occurring in nature. They are already available in nature. Okay, so the standard formation of these elements, okay, and this one, okay, is taken as 0. The heat of formation of all the elements in their standard states are arbitrarily assumed to be 0. So these are already occurring in nature and we don't supply any energy to prepare them specifically, and in its pure form in standard state their enthalpy of formation is equal to 0. Okay, so what are they? Carbon graphite, nitrogen gas, oxygen gas, hydrogen gas, water liquid and not vapor, okay, and bromine liquid and not vapor. So you have to remember this, and iodine solid, not your liquid or gas. Then chlorine gas, then S8 sulfur in rhombic form and not in orthorhombic form. Then all pure metals, okay, so any pure metals not in the form of alloys or not in the form of salts, we are taking it as 0. For example, silver, copper, calcium, aluminium, sodium. So we have to take them as 0. Okay, so while choosing this, okay, for the preparation of any substance, I have to choose. See, hydrogen is present and oxygen is present. So what is the source of hydrogen? I have to choose hydrogen gas because in the pure form I have to choose. Okay, then oxygen gas. Okay, then what you have to do? This is 1 mole of the product, 1 mole of the substance you are preparing. So you have to keep this intact. You should not touch this while balancing. Okay, keeping this as 1, you have to balance the rest of the things. See, hydrogen 2 is already present here, hydrogen 2 is already present here, only 1 oxygen, so here O2, so I am putting it half, because half into 2 will give you 1. Half into 2 will give you 1. Okay, so this is the standard enthalpy of formation of water. So for example, if you have to prepare HBr, so what are the components, students? Hydrogen and bromine. So what elements you will choose? So here hydrogen gas, and you have to choose bromine liquid. Okay, only these are these elements, these are the sources of these elements. Okay, so only these sources exist in nature in pure form. Okay, so here then this is 1, so you should not touch this, you should not disturb this. Okay, so without touching this we have to balance the entire equation. So 1 hydrogen is there, so to balance that I am putting it half, and 1 bromine is there, so I am putting here half. So if there is any equation like this, see here hydrogen plus bromine gives 2 HBr. You can ask me, ma'am, this is also balanced, why can't we write like this? No, you can't write like this for standard enthalpy of formation. What does it say? The change in enthalpy when 1 mole of a substance in the standard state. See, the change in enthalpy when 1 mole of the substance. Okay, only 1 mole. So the energy involved in preparing 1 mole of the substance is considered as enthalpy of formation. Okay, students. So now coming to combustion. So enthalpy of combustion, the enthalpy change when 1 mole of a substance burns with oxygen, okay, under standard state. So combustion means reaction with oxygen only. For example, if you are treating, if methane is undergoing combustion, so you have to treat with oxygen. So here also only 1 mole of the substance can undergo combustion. So how to write the product, students? So you don't need to worry. Any carbon, okay, convert to carbon dioxide. Any hydrogen, convert to water. Okay, so keeping this intact, don't disturb this, balance the rest of the equation. 1 carbon and 1 carbon, then hydrogen is there, hydrogen is 4 here and 2 here. Okay, then oxygen. So you have to first balance the carbon, then your hydrogen, then only oxygen, because oxygen can take part in more than 2 products like that. Okay, so carbon, hydrogen and oxygen. So here then oxygen is here 2 and here 2 here, so totally 4. So here I am putting like this. Okay, so this is what enthalpy of combustion. The energy involved in the combustion of 1 mole of the substance, we are considering it as, okay, enthalpy of combustion. Then so how these data, how we are going to relate to our numericals? See, they will be giving one reaction. I already told you. They will be asking the enthalpy of the reaction of that particular enthalpy change in that particular reaction. So if provided the enthalpy formation data are given, the formula that you have to use is, okay, so here the enthalpy of the reaction, standard enthalpy of the reaction, how it is related to the formation data is sum of the enthalpies of the products, okay, minus sum of the enthalpy of the reactants. Okay, here it is opposite. The enthalpy of the reaction is equal to sum of the enthalpies of the reactants minus sum of the enthalpies of the products. Okay, so you don't have to worry. We are going to solve numericals based on this formula and you will get to know it. So the question number 6.3 from your book back exercise, the enthalpies of all the elements in their standard states are 0. So we saw, no, the elements in their standard state, okay, so they are 0. Okay, so next coming to the second question. Say to save time, no, I have wrote all the data given. The enthalpy of combustion of methane, your methane is CH4, your graphite, simply graphite is given, that means your carbon graphite, that's it. And your dihydrogen means H2 at 298 Kelvin and the data are given, okay, respectively. The enthalpy of formation of methane is, see students, you have to understand the question properly. So these are the data given to solve this equation. What is the equation? What is the reaction? Enthalpy of formation of methane. Okay, so for the enthalpy of formation of methane, certain amount of enthalpy is involved. You have to solve this, okay, based on the data given. Okay, so what are the data given? So combustion, methane upon combustion means reaction with oxygen. Okay, so what will be the product? Convert all the carbon to carbon dioxide and hydrogen to water. So keeping this intact, you have to balance this equation because this is the combustion equation. Graphite plus oxygen give you carbon dioxide. I have balanced this, and hydrogen plus oxygen gives H2O. Okay, so keeping this as 1 mole, these are 1 mole, you should not disturb this. Okay, so this is perfectly balanced and the data have been given. So what is the reaction they have asked? The enthalpy of formation of methane. See, enthalpy of formation of methane. Methane must be prepared in 1 mole. So carbon is present and hydrogen is present. What are the source of carbon and hydrogen? So I can take carbon from carbon graphite and hydrogen from hydrogen gas. Okay, so keeping this intact, I have balanced. So one carbon here, four hydrogens are there. So I have put 2 here, 2 into 2, 4. Okay, so this is the reactant side, this is the product side. So you have to find the enthalpy of this reaction. So which formula will you use? Provided the combustion data are given. Combustion data are given. So you have to use this formula, isn't it? Okay, the enthalpy of the reaction is equal to the sum of the enthalpies of the reactants minus sum of the enthalpies of the products. So this is the reactant side, this is the product side, isn't it? So reactant. So how many moles of graphite is present? Only 1 mole. So 1 into enthalpy of combustion of carbon graphite, okay, plus there are 2 reactants, isn't it? So 2 into enthalpy of combustion of hydrogen. Okay, so this forms your reactant, and then subtracting the product, 1 mole of enthalpy of combustion of methane. Okay, simple. Then you have to substitute all the values, that's all. What is the combustion value? What is the enthalpy of combustion for graphite here? Take from here. Okay, so 1 into minus 393.5. Okay, so plus 2 into enthalpy of combustion of hydrogen is 0.285.8. Okay, so minus 1 into for methane it is minus 890.3. So while solving this, you will get 74.8 kilojoules per mole. Isn't that very simple, students? Okay, this is actually very simple. Then coming to the question 6.11. The enthalpy of combustion of carbon to carbon dioxide is, the value is given. Okay, the value, combustion value for carbon. Calculate the heat released upon formation of 35.2 grams of carbon dioxide from carbon and dioxygen gas. See, so you have to analyze it. This is very simple reaction. See, carbon is undergoing combustion to give carbon dioxide. The reaction is already balanced. Okay, during this reaction, this much amount of energy is released. Okay, see, all our reactions only, the type of this reaction is combustion. That's all. Okay, so here they are asking, if see here, how many moles of carbon dioxide is produced here in this reaction? It is 1 mole of carbon dioxide. 1 mole of carbon dioxide is produced in this reaction, and during that, this much amount of energy is liberated. They are asking, calculate the heat released upon formation of 35.2 grams of carbon dioxide. So 1 mole of carbon dioxide is equal to how many grams, students? Is equal to 44 grams, isn't it? 1 mole is the molecular weight of carbon dioxide. Carbon dioxide, it is 12, and 2 oxygen is present, plus 2 into 16. So 12 plus 32 is equal to 44. So 1 mole of carbon dioxide is equal to 44 grams. Okay, so they are asking in grams. So simple cross multiplication. So to prepare 44 grams of carbon dioxide, how much energy is released? Minus 393.5 kilojoules per mole is released. Okay, this itself is mole. Okay, kilojoules is released. Then if I have to prepare 35.2 grams of carbon dioxide, then how much energy will be released? See, you know that your del enthalpy is extensive property. What is extensive property? It depends on the quantity. It depends on the quantity. Suppose if you double the, if you are preparing 2 moles of carbon dioxide, then this energy will also get doubled. If you are preparing half mole of carbon dioxide, this will get reduced to half. Okay, it is an extensive property. So directly we can solve this. So cross multiplication, 35.2 into minus 393.5 divided by 44. The answer is kilojoules. So the enthalpy to prepare 35.2 grams of carbon dioxide is, I just cross multiplied. Okay students, this is your question number 6.12 from your book back exercise. Here the enthalpies of formation of carbon monoxide gas, carbon dioxide, N2O and N2O4 are given. Okay, enthalpy of formation data are given. Find the value of the enthalpy of this particular reaction. Okay, the enthalpy of this reaction you have to find out. Okay, so the formation data are given here. So which formula you will use? So you have to use this formula here. Okay, so what is that? So the enthalpy of the reaction is equal to sum of the enthalpies of the products minus reactants. Okay, so here, so how many products are, this is already balanced, but check once again. Okay, it is given in the question as such. So product side, how many, see this is the stoichiometric coefficient. Okay, so how many moles have been prepared, this we have to be very careful. So coming to product side, so N2O and carbon dioxide in product side, so 1 into, okay, so the enthalpy of formation of N2O plus 3 into enthalpy of formation of carbon dioxide. Okay, product side finished. Then coming to reactant, 1 into enthalpy of formation of N2O4 plus 3 into enthalpy of formation of carbon monoxide. Then you have to just substitute the values, that's all students. So here the enthalpy of formation of N2, where it is given, okay, this is the third value. Okay, so sorry students, this is the third value. Okay, so for N2O the enthalpy of formation is 81. Okay, plus 3 into enthalpy of formation of carbon dioxide, the second value, it is minus 393. Okay, so the reactants, the product side is over. So here 1 into enthalpy of formation of N2O. Okay, so it is 9.7. Then 3 into enthalpy of formation of carbon monoxide, it is minus 110. Okay, so it is 81 plus. I have solved the question students, so the values comes out to be this. This is just mathematics. Okay, so just multiplication. So in order to save timing, so I did that. Okay, so just this is 3 multiplied by minus 393. Okay, so 1 into 9.7, 3 into minus 110. Okay, so just solving this, this is your answer. So this is your question 6.14. Okay, so here some mixed data are given. See, the enthalpy of a common reaction is given, combustion and formation. Okay, if they have given in this pattern, then how to solve it? So this is very easy. Okay, these are the given data actually. And what is the question? Calculate the standard enthalpy of formation of methanol from the following data. Okay, so first I'm going to write what the what they have asked for. Standard enthalpy of formation of methanol. So methanol has to be prepared, isn't it? So standard means it has to be in 1 mole. What are the elements present students? Carbon, hydrogen, oxygen. So what are its standard form here? Standard form of carbon is carbon graphite plus hydrogen gas. Okay, then oxygen gas. Okay, then you have to balance it without disturbing it. So 1 carbon is present. Okay, so here 4 carbon, 4 hydrogens. So here I am balancing it 2. Okay, so oxygen is only 1, so half. Okay, so this is the standard enthalpy of the formation of your methanol. So for this reaction they are asking the enthalpy. Okay, so how to solve this? See, this is very easy. I am telling you. See, first of all, what you have to do is you mark this entire equation as X. Okay, then you mark the entire reaction as Y. Okay, you mark this entire reaction as Z. Okay, what you have to calculate the enthalpy of formation of methanol. So the enthalpy of formation of methanol is equal to, you are going to do. Here we cannot use any formula like this because mixed data are given. So what you have to do, you compare this equation with the given data. Okay, first of all, carbon graphite is there. Carbon graphite is present here. Where the carbon graphite is present? In the equation Y. Okay. So now check for the moles. Here also 1 mole. Here also 1 mole. Then check for the left hand side and right hand side. See, here also the left hand side of the equation, the carbon graphite is present. In the given data also it is present in the left hand side. That is the reactant side. Okay. So you don't have to do anything. So simply put Y. Okay. Then coming to H2. Okay, then coming to, where is H2 is present? In this equation. Then check for the moles. Here 2 moles, but it is here only 1 mole. Then what you can do is multiply the whole equation by 2. Okay, then you will get 2H2. Okay, then check for the left hand side, right hand side. See, here it is present in the reactant side. Here also it is present in the reactant side. Okay, then I am going to write it as 2Z. Okay, I multiplied, no, so 2Z. This equation is marked as Z, so I am writing it as 2Z. Then oxygen is present in all the reactions, so you need not do it particularly. Then coming to methanol. Methanol, where the data is given, methanol, this is present in this equation. Okay, then check for the number of moles. Here also 1 mole and here also it is 1 mole. Then check for the side. It is in the product side, but in the given data, it is present in the reactant side. Okay, so what you have to do, put minus X. Okay, so here the reactant side, it was actually situated in the reactant side, so no need to do, just add it. If there is a reverse, the one of the thing is present in the product side and one of the thing is present in the reactant side. Okay, then change the sign, that's all. Okay, then what you have to do is what is the value of Y? Okay, the energy released in the equation, you have to write this 393. Okay, plus 2 into what is the value of Z? Okay, 286. That's all. Then minus X. So what is X value? It is minus 726. Then you have to solve as so. While solving, you are getting the answer to be minus 239 kilojoules. Okay, students, so what you have to do, so the given data, okay, if the mixed data are given, for the given equation, check the element where it is present or the substance where it is present. Okay, then if it is present in the same site and in the same mole, don't do anything. Okay, so keep the, so write the you assigned alphabet as it is. Okay, so here hydrogen is present in this equation, but here 2 moles, but it is 1 mole, so multiply the equation. So what I am writing is 2Z. Okay, so here also reactant side, here also reactant side, so I am putting it plus. Okay, then coming to methanol, it is present in the product side and here it is in the reactant side, and here also 1 mole, here also 1 mole. Okay, so I am putting it minus X. Then you have to take the values. As it is. Okay, so 2Z means 2, put 2 and only the value of Z. That's all. Okay, if you solve this problem is solved. So students, I will meet you in the next video. In that I will be discussing the bond dissociation enthalpy and enthalpy of atomization, and one problem that students actually will usually will face it very difficult, but actually it is not. I will be solving that question in my next video. Thanks for watching.